Okay, so I've decided to start on a new page. So this is lecture number 12, and I'm going to do page 692, problem 3. And what the problem asks is this. You have the nucleus of helium nucleus. It has two positive charges and two neutral particles called neutrons and two protons. Okay, two protons, positive charges, and two neutral particles called neutrons, and that makes a helium nucleus. The mass of this object is 6.64 times 10 to the power 27, negative 27 kilogram. Now, you want to find the kinetic energy of this object at 0.2% of the velocity of light c. And the unit has to be in joules. What it means is, if you want to make this object move at 0.2% of the velocity of light, then what would be the kinetic energy that it would have? Then B is to give that kinetic energy in units of electron volt. And C is, in order to get that kinetic energy, what type of voltage, the amount of voltage that you have to apply. Okay? So, first of all, we know velocity of light c is equal to, actually is 2.99 times 10 to the power 8, but I'll use 3 times 10 to the power 8 meters per second. That's the velocity of light in meters per second units. Now, I'm going to calculate the kinetic energy, and the kinetic energy formula is half mv squared. So we know what m is, so all we need to know is what v is. And in our case, v is given as 0.2% of the velocity of light c. Okay? So 0.2%, what is that? That is 2 divided by 1,000. That's 0.2% of velocity of light c, which is 3 times 10 to the power 8 meters per second. That's the velocity. So then we can calculate the kinetic energy. Kinetic energy is half m is 6.64 times 10 to the power minus 27 kilograms, and half mv squared is 2 divided by 1,000 times 3 times 10 to the power 8 meters per second squared. Okay, so that's your kinetic energy. This is 8. All right. So all we have to do is just plug it in. So instead of just put it in the calculator, I'll do this. 6.64 divided by 2, that's these numbers. And then I have 2 and 3. So 2 times 3 is 6. So I can write it down actually, just to not to confuse you. 2 times 3, that's, don't forget, it's squared. Then I can write down all these exponents. 10 to the power negative 27. Then I have in the bracket 10 to the power 8 divided by, this is 1,000, so that's 10 to the power 3 squared, and the unit will be in joules because that's kilogram meter square per second square, so it'll be in joules. Check again. 1/2 is there, 6.64, 2 times 3 squared, 2 times 3 squared, 10 to the power negative 27, then 1 divided by 1,000, that is 1 by 10 to the power 3, 10 to the power 8 here, and squared. So now I can write 6.64 divided by 2 times 2 times 3 is 6. 6 squared is 36. But at this stage you can put 6 squared if you want. 10 to the power negative 27. Then 10 to the power 8 and 10 to the power 3. So you get 10 to the power 5. Because 8 minus 3 will be 5. So 10 to the power 5 squared. So that's 10 to the power 10 joules. So now at this stage I can put it in the calculator. So let me do that. So 6.64 divided by 2 times 36 gives you 119.52. 119.52. Then what negative 27, then what 10, so that's 10 to the power negative 17 joules. Or you can move 2 decimal places, 1.1952 times 10 to the power negative 15 joules. Okay? So that's the answer to part A, kinetic energy in units of joules. Now for part B, so that's result for part A. And for part B, then I have to find the units in electron volt. So you know that in 1 electron volt, there are 1.6 times 10 to the power negative 19 joules. Right? So electron volt, kinetic energy in electron volt unit is the answer, which is 1.1952 times 10 to the power negative 15 joules divided by 1.6 times 10 to the power minus 19 joules per electron volt. Right? So then the answer will be, let me do this. So in electron volt is 1.1952 10 to the power negative 15 divided by 1.6 exponent negative 19, and the answer is 7470 electron volt, or 7.47 times 10 to the power 1, 2, 3. I move the decimal place 3 places, 3 electron volt. Okay? All right. So if I make any mistakes, please let me know. Now, part C is to find out how much voltage is needed in order to get this kinetic energy. And the thing is that, as we remember, if we recall, if you have positive charges here and negative charges here between these two plates, if I want to accelerate a charge, and if the voltage difference is 1 volt, then the kinetic energy that it will have is at 1 electron volt. So that means if you have this much electron volt, then the voltage it needs is also this much volt, right? So the voltage difference you need is 7.47 times 10 to the power 3 volt. That's what you need. All right? So here, when I calculate this, right, one thing is I can also divide 1.195 divided by 1.6. I get that number first, so that's 0.7468. So let's say 0.747. So the answer I get is 0.747. That's the first two numbers divided. And this is 10 to the power negative 15, then 19. So I'll get 10 to the power positive 4 in electron volt. So this is, if I move decimal one place, it'll be 7.47 times 10 to the power 3 electron volt. So which is the same as this. So you can directly put in the calculator or divide the numbers in the calculator, but do this in your head and then you can get the same answer, which is more reliable because sometimes when you put these big numbers in your calculator, sometimes you can easily make mistakes. All right? Okay, so we'll quit here.